heating curves. So I'd like you to attempt to do this problem, pause the video, and once you've answered all three questions, then I will proceed to um, explain each one. Okay? So pause the video. All right. So let's see how you did. So it says here a sample of a molecular substance. Let me just kind of change this here. A sample of a molecular substance starting as a liquid at 97 degrees Celsius at 1 atm is cooled for 10 minutes. The heat of fusion for the substance is 148 joules per gram. This cooling process is represented on the graph below. This is a cooling curve, not a heating curve. So we're losing heat as we go down, right? We're told that the H of F of this substance is 148 joules per gram. So we're not dealing with water. Okay. We're also told that it's a liquid at 97 degrees Celsius. So right here, you're dealing with a liquid, right? And um, basically, it's being cooled down for 10 minutes. And notice that if we're going down and we're starting with a liquid, we're going to end with a solid. So this process here must be the process in which liquid becomes solid. One of the things I like to do when I do a heating curve or a cooling curve or any type of graph is to label, especially heating and cooling curves. Okay. Please note that we're starting with a liquid and not a gas, which everyone assumes that the first line is always a gas, but that's not necessarily true. That's why it's always important for you to read the introduction, read the paragraph that's describing what's going on. Just don't go for the first question you see. Okay? So pause, highlight like I did here, some key important. I bet you these numbers may be used in the problem. That's why they give it to you. All right, let's go to the first question. State what happens to the average kinetic energy of the molecule in the sample during the first 3 minutes. So the first 3 minutes would be from here to about here. So you cut off that line right there, and you're talking about what's happening here. What's happening to the average kinetic energy? Now, average kinetic energy is the same thing as saying temperature. So, what's happening to temperature here from 0 to 3 minutes? It's decreasing. And you would simply put here for 1 point decreasing. You don't have to explain because you're not being asked to explain. It just says state what happens to the average kinetic energy, and that is all. Second question. During the freezing point of the substance in degrees Celsius. So determine the freezing point. So the freezing point is right here. It's the process by which a liquid becomes a solid. So you stretch it over, and the answer is 80 degrees Celsius. Okay? So we got a point here already and a point here. And last but not least, determine the amount of heat in joules released from 64-gram sample of this liquid substance solidifies at its freezing point. So here you're going to use the Q formula. Q is equal to mH of F. Okay? So H of F can be the heat absorbed to melt or the heat released during freezing. Okay? So the mass of our substance is we're told is 64 degrees and 64 grams. Right? The H of F is not 334, which is for water. You're going to use this one is 148. right? So you multiply 60 times 148. Take out your calculator. I forgot to put my calculator on and try to figure it out. Okay, and that's basically it. All right, done.